Hello, and welcome to Ridgecrest Robotics and Space Program's third high-altitude balloon launch. I'm Leland.
And I'm Annalise. And we're your reporters for the day. So we'll be keeping y'all updated on everything that's going on. So we'll have our launch and everything after and before because we haven't launched yet. So
So for this launch, as if you've watched the other two, we always have this main goal. And the goal for this launch is that we're trying to break the high-altitude balloon record made by a high school team by 120,000 feet into the atmosphere.
So our goal is to go 120,000.
Is that like above sea level, or like, do we count sea level, or do we just count from when it?
You know, I have no clue.
I think it does. Because of
Sea
spot.
level. So it is sea level. So yeah, I mean that's pretty cool.
Launch a balloon off a mountain, we get there faster.
Yeah, well maybe. I mean, there's a bunch of science stuff that goes into it.
Science stuff.
Okay, just don't do that. So, yeah, so our goal is to go 120,000 feet, which is breaking the record. So,
You want to talk about the future goals for
our future,
next launch?
so one of our future goals is to launch an egg, like do an egg drop from space, do the highest egg drop. And was it last launch? Y'all sent up an egg. So last launch they sent up an egg to, test it and see how the egg did. It did pretty well, right? I wasn't on the team last year. He was.
I don't remember.
So.
I don't remember.
Well, I think it did good. I think that's what it was. And so our goal is to have an egg drop from space, which will be the highest egg drop. Also, one of our other goals is so we launch an Army man from the balloon, and so it'll fall like a parachute, all that kind of stuff. And we usually just have a phone number. This year, I think the launch team is going to go see if they can find it.
Recovery.
Recovery. No. Recovery is gonna find the balloon. Launch is gonna find the Army man. That's what we talked about in class.
That makes sense.
Yeah. So the Army man will drop from, I think it's 10,000 feet. And so the Army man's gonna fall, and so the launch team is gonna go try and figure that out and find it. But our goal in the future is to have a tracker on the Army man so we can find it easier. So we can drop it from a higher distance in the air. So yeah, that's one of our goals. Which
I believe you would say higher elevation.
Higher elevation, higher.
But the.
I'm not very like. What do you call it?
Sciencey person.
Yes, I'm not a very sciencey person. I like science and it's fun, but.
Vinegar and baking soda all day, every day.
Yeah.
But the reason why the egg drop and the Army men with the parachute are connected is because we want to see how this itty bitty motor works in space.
Yeah. So we have what is it called?
Servo.
Servo
Motor.
It's a servo motor. So we have a 3D printed box, and it's gonna end up. What is it called? It's gonna open at 90 degrees. Is that right? Yes.
90. Right angles.
Whatever. I'm not very good at math, so
Okay, so now you're not a sciencey person, and you're not a mathy person.
Yeah, that's how it works.
All right. How about the?
So, we are going to talk about what the members all decided or all voted on how high the balloon is going to go. Leland wrote them down. So you get to do that because I can't see it.
So I couldn't get all the members because, one, we didn't do this smartly. Just gonna admit that. Two, not all the people I asked actually gave me an answer. But we do have 4. That's such a great number.
I guess we can come up with ours too once we're done.
6.
We got it.
So what we're trying to hit is 120,000 feet. This is what our crew is estimating. So Jay is estimating 127,000 feet. 127. Yeah, I said that right. Sarah Kate and Samuel are both estimating 121,000 feet. And Mabry is estimating a 67,000 feet.
I mean, that's pretty high.
But it's not as high as we're going.
No. But I don't think he has.
I think his
there's
face.
mission control.
I think his face in us is wavering.
So, as mission control, they have all their laptops plugged in, and so they'll be putting their computers onto the screen, and some of those will have we have our tracker, we have our data logger, we have our what is it called, FPV. So yeah.
So what is the difference between the recorded video that we're gonna have on the what's it called, the Insta360 we're sending out,
Insta360,
and the live pictures?
So the live pictures,
like the FPV.
Yeah. So the FPV is going to.
What does it stand for?
I guess I should say that because I didn't know what it stood for. So FPV stands for first person view. So they are live pictures coming in to our laptops. And so also, I'm going to pause right there, but I think our balloon that's the FPV right there.
They don't see it. This is only what you see.
No, whatever. So top right, yeah, okay.
Now we know that is a picture of somebody's hand and grass, but
yeah.
Hopefully it will look a bit better when it's in the atmosphere.
Yeah, so it comes in pixel by pixel, as y'all can see right there. It is coming in pixel by pixel, so someone has turned it on. They are working really hard at launch site right now, getting the balloon ready to launch up into space. So that's pretty cool. I know. I'm excited to see what kind of pictures we're going to get from space. I don't know about you, but
yes.
I can't wait to see what's going to
I remember last year's were pretty cool.
Last year's were pretty cool. I don't remember seeing last year's, and I wasn't on the team. But I'm excited to see this year's and just see all that ends up coming on.
Okay, so back to the original question.
Yes, back to the original question. So that's the FPV, as y'all just saw. So that will be coming in pixel by pixel on our computers, and be ready for that. But I think you should talk about the Insta360.
It's a camera.
Yes, very descriptively then.
It's a video. It's basically a GoPro, but if you look at it, it's a square and there's a globe for the camera, which gives it the name 360 because on the website you can click and drag and you have video everywhere.
Yeah, so.
Which is pretty nice when you're in space.
Should we check on the launch site? Should we see what they're doing on there?
Yes, we should.
Here's launch site. We have Alex, who is holding the balloon. He is our mission control specialist. That is Matthias. He is the what is he? The helium? No, he's not the helium. He's the Insta360.
Sure.
Yeah. So that's our balloon. It's full of helium and ready to go up when they let go of it.
So, fun fact, that's what the helium looks like now, down closer to the ground. Mm-hmm. But the farther up it goes, the more the atmospheric pressure is less. So it'll get bigger and bigger until eventually it explodes.
Yeah. So as you can see there, they are wearing gloves. So there are certain oils on our hands that cannot touch the balloon.
It will weaken the structure and make it pop early.
Exactly. And so we wanted to go as far as possible, as we've discussed. We
120,000.
As I was about to say, we want to go 120,000 feet. And so they're wearing gloves if you were touching the balloon. So that
don't look at the dude without the gloves. He's okay.
Oily fingers. There. So so helium is ridiculously expensive.
It's not a natural resource.
It's not a natural resource.
It doesn't spontaneously come.
Exactly. So with that, we have Airgas who donated our helium, and so that is a big help because helium is really expensive, and for them to donate as much helium as we needed, so we needed a lot of helium, obviously, because it's a pretty big balloon, as you can see.
Now you might be wondering, how do we know how much helium goes in the balloon? And I'm just going to answer it. We don't use the pressure gauges because there's always a chance there's too much or too little. Because apparently it's really hard to measure something you can't see.
Yeah.
So we have this very scientific way to do it. So there's this bucket. We tie this bucket to the balloon. And there's this really complicated, I'm just going to guess it's complicated, math problem that shows how much weight goes in the bucket. And that much weight, the balloon will start like levitating the weight. Not floating off, but levitating. And that's how we know there is enough helium in the balloon for it to go as high as we want it to.
Yeah, so as you can see, they are holding onto the balloon so it doesn't
how much?
fly away.
Cubic feet.
So they are, keeping it steady for us so that when it comes time to launch, they will let go and it'll go up into space, which I think is pretty cool. So
atmosphere, stratosphere, other spheres.
What?
Just naming all the spheres of the
just naming all the spheres.
Atmosphere.
Yeah. So, as you we've put a lot of work into this, and so watching it, seeing it on the screen, even we're obviously not at the launch site, but seeing it on the screen is just so cool to see all the preparation and hard work that we've put into this. So yeah,
it's a lot of helium. 145 cubic feet of helium. So basically, you can measure cubic feet of a gas apparently.
I didn't know this. But that's a lot of cubic feet. 145, is that what you said?
Yes.
That's a lot of cubic feet.
But with the pressurized gas, as I was saying, it's really hard to measure it into a container. So
specifically,
you can't have 145. You can, but helium is so small there's a chance of some of it leaking out, and it'll be less than what we need.
So
we have a big tank.
Yeah, we have a huge tank of helium. And again, we thank Airgas for donating all this helium to us because it is a big help for us to be able to have this helium.
And if you didn't know, next time you find yourself at a hospital, around the back where they have big tanks of the gas, pure oxygen, is it ammonia?
Maybe.
I don't know. But all the gas is in the back. Airgas also, I believe, is either the largest or second largest, largest or second largest supplier of gas to the world.
So they even give gas to
the hospitals.
To the hospitals to keep them going. That's pretty cool. I didn't know that.
People need pure oxygen sometimes.
Yeah, sometimes. So launch is. We're gonna launch in about
19 minutes.
19 minutes. Oh, you brought it up for me. Thank you. So that's pretty cool.
And correct me if I'm wrong, but I believe where the countdown is, that's where we get our featherlight data.
Yes, it is, I think. Yes, so it is. So also on that computer is, so once we launch, we will get our featherlight data. Wait, yes.
Once we launch and a little bit after.
Yes,
because
a little bit after we launch, we will start getting featherlight data. So that'll track the height, right? So that'll track the altitude that we end up going, how far we go.
Air pressure,
yeah.
How the velocity of it spinning.
Yeah, it'll show us. Won't it show us when it not explodes?
Well, it won't really show us when it bursts, but it'll show us when it goes from high elevation to lower elevation.
When it all of a sudden just starts dropping, that's when we know it has,
What else is there?
burst.
There was, the balloon. So, it's not just a string on a balloon, and it just very calmly goes. No, the string is spinning around it.
String is constantly spinning. So right here we have our GPS spot tracker. Spot GPS. Sorry, I said it wrong. So every 5 minutes we will get a ping, and it'll show us where our balloon is.
Right now they're just moving it around so it doesn't turn off.
Right now, so the reason you see so many zigzag lines is because, so if we keep these things like the spot GPS, they will shut off automatically after not moving for so much, or for a certain amount of time. So at launch site, they are continuing to keep it moving so it doesn't fall asleep on us, and then because we don't want it to fall asleep and then not be able to.
Because fun fact.
Do that. So we are going to actually call launch site right now. to start getting things moving. Let me go if I can find it. So we're calling launch site to see where they are and getting ready to launch. It's exciting. Hello.
Okay. Hold on. Yeah.
Might I ask who holds the phone?
Yeah, who are we talking to?
This is Cooper.
Well, hey Cooper. So Cooper is our launch site director.
Coordinator. Yeah.
Director.
Funny.
So Cooper, what's going on over there?
Sorry, repeat that?
What's going on over there?
We have the balloon filled and we are ready to launch.
You are ready to launch. Okay, so now we are going
What is?
to.
Hey Cooper, where are we launching from this year?
Yeah.
We are launching from Mount Gilead.
So Mount Gilead, isn't that where we've been launching for the past couple years?
We launched there once.
Yeah.
The last time was a cow pasture.
Okay.
Yeah.
Well, so we thank Mount Gilead for letting us launch our balloon from there. So what are y'all getting ready to launch? Like what is going on tech-wise, I guess?
So we have for the what we're setting up. We are setting up a parachute.
Mm-hmm.
Is it the So we're setting the parachute up to slow its descent when it's coming down.
Yeah.
And one of those probably closer and stuff. Next we have is it the Featherlight or is it Featherlight though? So that's the GPS. This next one is the GPS.
Okay.
So this is where we're gonna track it.
Okay, so that's what we're gonna end up getting our track from. Okay, that's pretty cool.
Next we have quite a few things.
Okay.
First is the 360 camera.
Yes.
That's going to be what's going to record 360 degrees.
Mm-hmm.
I believe we're gonna get the recording after. Next we have the picture right here.
Yes. Okay.
And then we have the Army Man launcher.
Okay, so that's the box where the Army Land's gonna end up launching out of.
Yes, it is.
Okay, that's pretty cool. Okay.
Then we have the FPV camera.
Okay, so that is the first-person view camera that will be getting pictures from space, live pictures. So that's pretty cool. And
then finally we have the Featherlight.
The Featherlight. So.
Featherlight on the bottom.
Yeah. So, what does the Featherlight do again, Cooper?
I believe it records everything.
Mm-hmm.
So altitude, how fast it's spinning, things like that.
Okay, so that's pretty cool. You have a pretty cool setup right there.
And we can't forget the balloon.
Oh yeah, and the balloon. Yeah, the big part of our mission.
Behold, a line of instruments. Where's the balloon?
I'm glad we have the balloon to take our line of instruments up there.
Budget cut.
Okay. Yeah, sure. Okay. So we are about to start getting ready to launch. So yeah. There's a lot going on over there.
There sure is.
Okay. So why is Gunner walking around?
What's he holding?
What is he holding?
He's holding the GPS.
So why does he have to keep walking around?
If he stops walking around, then it could turn off, and our flight wouldn't work. We couldn't track it.
Okay.
It's got a mechanism in it. If it quits moving, it'll save the battery at being every 20 minutes.
Okay.
And obviously we don't want that. We want to.
We want it to ping as.
To be giving us all. Yeah.
Yeah. Okay.
All right.
So he has a pretty important job keeping that GPS on.
Do we have the flight prediction? I mean, not for no offense, Cooper, but not for you, but for mission control. Do we have our flight prediction?
Yes, we should at least. Okay, so
There.
here's our flight prediction. So the green is where we are launching from, so that's Mount Gilead. And then the yellow is where it is predicted to burst. And then the red is where it's predicted to land. So we are in Georgia, it looks like. Camellia, really close to Camellia, Georgia. So that is where it is predicted to fall. Hopefully.
Actually, the balloon, in glass, our balloon is too big for the prediction software. Like, they don't have a balloon big enough for us.
Yeah, so we had to put in the max amount of weight. Is that the weight?
No, it's how big the balloon is.
How big the balloon is.
So really, we're going a little farther.
Yeah, so really we're going to go a little bit further than that prediction says because
longer,
we have a little
so
bit of a bigger balloon, but it'll land somewhere around that area.
If I could pronounce that out loud, I would say it out loud. But, so, the city to the east of...
Okay, so I still have launch on the phone. We are about to go to our go, no-go sequence. So, is launch site still there?
Yes, we are.
Okay. Let's come and get our go, no sequence ready.
Okay.
Okay. Okay. So we have our go, no-go sequence getting ready. So, let's go. So, we have the countdown on the screen. And okay, launch site. Are we go or no go?
Go.
Go.
That's it.
Spot GPS, go or no go?
Go.
Data logger, go or no go? FPV, go or no go?
FPV is a go.
Okay. So, we're going, so we are super close to launch, guys, and we are super excited for this because we have worked so hard for this.
So many weeks of just
I know,
learning
so many weeks of learning all of this and getting it all ready. We are super excited for this. So there's been a lot of preparation that has gone into this, and it's cool to be here and having the go, no, go sequence set in motion, and we're getting ready for countdown.
I'm ready to go.
Leland's ready to go. He's going. So just a reminder, we are going, our goal is to go 120,000 feet. How high do you think we're going to go, Leland?
Never put a lot of thought into it. I would say 130,000 feet. Probably.
130,000? That's our mark is actually. I was gonna say 135. I think we can do it. Honestly, I'm so ready to see how this is gonna go. So there's launch site. They are getting ready.
To let go of the balloon.
I know here in Mission Control we are really excited. Excitement's brewing. We're getting super excited for this. So
Mission Control, can I get a what?
Okay, they've been knocked out, but okay. So there's Mission Control. As you can see, they're so excited to, get this pumped up. We're so excited. We're ready. We're getting close to going. Yay! So I'm really excited. What about you? I'm super excited.
We've been here a little longer before we got live, and they've been holding that balloon for the past hour.
Yeah, they had filled it up when they got to launch site, so they've been holding it for the past hour. That is a lot to make sure you are not going through it, and that's just a lot.
Just imagine the grip strikes on that poor fellow over there.
Yeah, so that's actually my brother. My brother's the one holding the balloon, so he was willing to go and help them out.
And if the vehicle in the back, the very big bus,
yes.
That is our recovery vehicle.
Yes, our recovery vehicle. It'll have mean, they're gonna go.
And the box on top of their covered vehicle, I
Yes.
think, is the antenna.
Yes, so that's the antenna. That's what we're gonna be getting the feed to get our FPV photos.
So the FPV works by, it pixelates it by shooting it back down to us. With,
Yeah.
is it Laura Ann or Laura Wan? Laura Wan?
Laura Wan.
Laura Wan. Which
Yeah.
is, it's not as big as an umbrella, but it's a more consecrated umbrella.
Yeah.
And we need to constantly be under the, like,
Yeah, they have to constantly
pretty consistently be under the balloon.
changing that to go into the right direction so that we can see the FPV photos and keep getting can't speak to it, so we can keep continuing to get them.
So what's going to happen is our Spot GPS tracker, yeah.
Yes.
Sarah Kate, she's going to get the coordinates from the last ping,
Yes.
send the coordinates to, I believe it's Ty,
Yes.
our
So
recovery
he's gonna send them to
director.
Ty,
And then he's going to put it
into Google Maps.
And then Google Maps is going
And then
to
he's
put a
going to
ping.
tell our driver, Mr. Greg.
Ah.
No, not Mr. Greg.
Mr.
Rich. Mr. Greg is our, like,
all-around person.
all-around person. Director. He's gotten everything set up for us. He's the one who's been keeping us going. But Mr. Rich is going to be driving, and so Ty, who is our recovery director, he is going to give give the directions to Mr. Greg, because obviously the balloon's going to go in places where we cannot drive. It's going to go where we are not able to drive. So they have to find a route to follow this balloon, and so that's pretty cool.
And quick shout out to Ridgecrest Baptist Church.
Yes.
And it was Sarah. It was the pulpit that just flashed on screen.
So Ridgecrest Baptist Church is where we are, where our mission control is stationed. This is where not all the excitement, because but this is where our Spot GPS is, our FPV, first person view camera, our data logger, and where we are right now. So there are 3 minutes to launch.
I'm waiting.
I cannot wait. This is so exciting. I'm excited to watch the balloon go up.
Yes.
Honestly, I'm so excited for that. So I think launch site is just, they're ready
Just
to go.
there, holding the balloon.
They're ready to go. So is mission control. We're all ready to go.
That one guy.
That's Mabry. He is our FPV manager, so he will be getting those first-person view camera photos into the what do you call it? What is it called?
The final check.
Yeah, the final check. They are doing the final check right now. They are checking to make sure everything is on, everything is running. Mission Control is getting their computers.
They're putting the GPS in the little pouch it's supposed to be in.
Yes, they're putting the GPS because it has been moving around for
a while.
So, yeah, that is exciting.
2 minutes till launch.
2 minutes till launch. Let's get it. I cannot wait.
Can we have the countdown screen, please?
Yes. If we can get the countdown screen, that would be great. Yes.
So now we're just
Beautiful.
going to stare at this.
No, we're not going to stare at it, Leland. You are staring. Time's going to go just by so slow if we just stare at the launch countdown. So,
My watch is ahead.
yeah. I'm excited.
Yes, I want this balloon to go up into the air.
I think one of the things I'm most looking forward to is seeing the FPV photos come in. Just watching them come in and getting those photos from space. I'm super excited.
I hope we get
and
another.
there are some right now. They are looking at the sky because that is where
That is where the sky is.
our FPV is right now. So it's blue. It's really cool, honestly. It comes in pixel by pixel, so it's not just like you're getting a photo. You can watch it come in line by line as it's coming in, and that's pretty cool. There's some wires back on the ground apparently.
I wonder why it takes longer for the ground than it does for the sky.
Well, so there's more going on the ground.
That is true.
So if we can get the countdown, because it's almost time to launch.
10, 9,
9,
8, 7,
6,
5, 4, 3,
2,
1.
And there it goes! Woo! That was so cool.
Fly
Honestly.
high, little birdie.
Fly high balloon. That is pretty cool. I mean, just watching it go up. It goes up like
1,000 feet per minute.
Yeah, I was just about to say that. It goes up pretty fast.
So we won't have visual of it the entire time.
Yeah. So you can see there's the little balloon. There's our FPV. It is coming in. It was watching us.
This is when we were holding on to when they were holding on to the string and it was
right
kind of
before
levitating.
They launched it.
Do you know what I hope we get?
What?
I think it was the first year or maybe this last time we did it, but we got like a great picture of Ross Clark Circle.
That's pretty cool. Oh, and there is the FPV. As you can still see in the launch site in the top corner, you can still see part of the balloon, and now it's gone, but it's okay. There's our FPV, so it's coming in. As you can see, it's not going to be a perfect picture every time. It's coming in. It's gonna, be, a little harder to see that.
Cause think about it, this thing is spinning kind of fast.
Yeah, I mean, it's pretty cool to watch.
Have you ever taken a picture on a swivel chair?
I have not. I don't like swivel chairs.
It doesn't work. I'm just
As
gonna
you
tell
can
you
see, the FPV is still, it's taking pictures constantly. It's constantly sending them in. Now, they won't be good every single time, but we will get a couple good ones, and they're going to be great.
See, we might have a little
So,
strip where it's just kind of missing
Yeah.
sometimes.
So, it goes a lot into what
Let's
we
see,
do.
my folder of destiny.
Your folder full of all kinds of stuff. So,
Where did I put that?
Leland,
Yes.
do you like jokes? I'm sorry, didn't mean to offend. Did not mean to offend.
All right, what you got?
What you got? What do I got? Okay. What is an astronaut's favorite key?
Ooh, wait.
Like on a laptop. Like you're looking at a
The
laptop.
space bar.
I shouldn't have given you any more contacts. Okay, do you have one for me? I'm sure you do. You have a whole
Maniacal
kind of
laughter.
paper over there. So there's
What does an astronaut call his ex from space?
Does an astronaut what?
Call his ex from space.
Ooh, I don't want to know. What is it?
SpaceX.
That was...
How does an astronaut organize a party?
Okay. Pause that for 1 sec. Do you see we have the data logger on in that top corner above
Yes,
the FPV?
on
We have
this
our
time.
data logger. That's cool. So
I'm just glad it's on this time.
Yeah. So last time there were some complications and we did not end up getting our data.
By complications, it wasn't turned on.
Yes.
Just gonna stick it to it plain.
So this time in class we went through a whole bunch of
Practice.
practice
Flipping the
and
switch from off to
practice
on.
switching it on and off, making sure it's on, stuff like that. So that's pretty cool. So
Now, one of the, obviously, I'm just going to say one of the most important parts of a balloon is the helium in the balloon that makes it go up. The helium that lifts it. To learn more about this, I interviewed Caleb, who is our helium manager.
we did interview Caleb.
However, he was out sick today, but we still have the interview with him. So let's take a look on how that interview was.
Yeah. Well, it'll come on eventually. Takes a sec to get it on, because there's a lot of preparation that goes.
In the meantime, I have a joke.
You have a joke.
Uh-huh.
Well, you have a whole thing to read.
How did the space teddy bear cross the road?
Okay. The interview is ready, so let's watch this interview.
Hello, my name is Leland, and this is Caleb. Caleb, say hi.
Hello.
Caleb, what is your job title?
My title for the job is Helium Manager.
What does that job entail? Like, what do you do for being the helium manager?
Mostly filling up the balloon with helium, but also calculating the cost for the helium and just making sure the balloon doesn't fly away.
So you're the man who holds onto the balloon at the bottom. You're just looking up at the balloon. No, please, stay.
Pretty much.
So the cost of helium. Is helium expensive?
It is very expensive. I don't know the exact cost, but it's going to be around $120.
All right, that's more than I make. I'm broke. But what is a challenge you have faced being helium manager?
Some of the challenges as helium manager is the cost of helium, after all, and also helium is not a natural resource, meaning we only have a limited amount.
Oh, I did not know that. But what is something you've learned from being helium manager this year?
Well, probably the most that I've learned is why we need the helium and why there's not many other things that would work for now. But the problem with helium is that because it's so small, if there is a leak in the balloon, it'll come out and we'll have to restart all over again.
That's not good. Not like last year or last launch. I had another question. Why are we using helium instead of, like, say, hydrogen?
Because helium is an incredibly light resource, and also, while it is small, if it does get through the balloon, that will help show us that there is a leak, and so we will know what to do right next time.
And have you been on the team at all the previous launches?
I've been on the team for the past 2 launches, but only in mission control.
What was your job there? Just wondering.
Mostly switching between pictures and videos, but last year I also did some of the sound.
Nice. So you got to switch between the Stratostar and then my face. Thank you for your time, Mr. Caleb.
Thank you.
So we actually, while that video was going, we got featherlight data. So our featherlight is turned on.
It's on.
And
Yes.
we are seeing this come in. So it is showing us where it is.
7,839 feet
so
above
it's
sea
already
level.
really high up. So that is amazing. I mean, it travels at 1,000
Feet per minute.
and it's already been like 7 minutes, almost 8. So that's pretty cool. Also, while that interview was going, we had our Army man deploy, and they have eyes on it. So they are going to get it right now. They are following it, and they're gonna bring it, hopefully get it back, and that's exciting.
Yes.
I know I'm excited to see like what that was and how well that did. So yeah, that's so cool.
I mean, I've always liked the Army Man idea because it was the second launch, and there's the problem of the egg drop, and how are we going to test out the servo?
Yeah.
And this sounds like I'm taking credit for it, but I'm really not. I came up with the idea of an Army Man with the plastic little parachute.
To test it.
To test it out.
Yeah, I mean, that's honestly, it's a great idea. I'm ready for that.
Do we have any good FPV pictures?
Do you have any FPV photos that we can show that are gonna be great?
Is that the horizon?
So yeah, that's exciting to see. I mean, it's already so high up.
The little blue blob is the, let's see, FPV's down. That's the featherlight.
Yeah, that's the featherlight. So that's great.
Oh, that's not the horizon. Those are clouds. Never mind. Forget I said anything.
So we have another interview with Eli, our launch site coordinator. He is the one who decided where we were going to launch from.
Did we ever do that?
And yeah, so we're going to watch him. Hello, my name is Annalise, and I'm here with Eli. And we're going to just talk about your job. So what is your job?
I'm launch site coordinator.
Okay.
I basically have to find a place where we can launch the balloon from.
So you find the launch site.
Yeah.
So, how, like, I need words. What, do we have a launch site yet, or
No, we don't.
are you, I guess you're looking at possible places to launch. What is entailed in that? So, like, what do you have to do to find a launch site?
So we need to look for. We need to have an open space to where it can launch.
Mm-hmm.
The weather's also a big thing. Wind, all that.
So you just need a place where, an open space where nothing, our balloon won't hit anything. And I guess the weather also needs to be good. So have you been on the team before?
No.
No, so this is your first time? What made you decide to choose launch site coordinator?
Well, Mr. Gregg picked me to do it.
Mm-hmm.
Yeah.
I mean, that's pretty cool. You must, I think you have a really good, what do you call it? I don't know what it's called. Coordination, I guess. I don't know. So, what, hang on. What is something you have learned from doing your job? Or have you learned anything? No.
I haven't learned anything yet. I'm mostly coding the servo motor right now, so that's what I've been doing.
What is a servo motor?
It's the thing we're launching. It's the thing we're using to launch the Army Man out of the balloon.
Oh, so I'm guessing the Army Man, he'll be in a box.
Yeah, it'll open the hatch.
Oh, that's pretty cool. I couldn't do it. I'm not good with computers, and so coding is not my thing. What has been your favorite part about doing your job?
Well, I like coding.
Mm-hmm.
I like coding stuff, but that's probably my favorite part of it, being honest with you.
Yeah, well, you have a really cool gift, and you're using it perfectly. I can't do that, so I'm glad someone else is doing that. Well, I think that's all I have. So thank you for letting me pick your brain for your job. So, that was Eli. He was our launch site coordinator. It was really fun talking to him and getting his little insight on that. So right here we have the Featherlight.
Looks like we have more data than last time.
We do have more data. So it is at 14,827 altitude right now.
So feet.
So feet, altitude feet. You know what I mean. At least you do. Sorry guys to everyone else.
Travel the whole 0.4 miles.
Yeah, so
0.9 miles.
as you can see, you are watching it, you're watching it turn and, turn on and all that kind of stuff. And I just think that's so cool. And, I just love being able to see the, Featherlight turn on. So the vertical rate is 1,086 feet per minute. So
that's how high it goes.
That's how high it goes. So that's at the vertical rate right now.
Okay.
So that's cool. The as you can see, the latitude and we have the longitude. The speed is 10 miles per hour. The heading is 24 degrees.
What's the heading?
You know, I think it's the top, so it's how, like, I don't actually know the, like, thing behind it. And then it's traveled 0.9 miles, so that's pretty cool. So the vertical rate, and that's all that's so cool just to watch. I mean, as you can see, like, that already went up, so it's now up to 12,417 feet in altitude.
It's gonna keep going up.
It's
till
gonna
it
keep
bursts.
going up, and
Hopefully it'll go past or at 120,000
yeah,
feet.
if it goes at 120, we'll be happy, because that's just, it means it's ready. It means we beat the record, and we're so hopeful, like crossing our fingers that it's gonna go up, and we're just so excited.
I want to break the record.
So if you can see on the FPV, we have the box at the bottom, and so on that box we have our GPS, as we talked about in the beginning with our launch team. On that
I believe
box,
that box is the featherlight.
well, yeah,
Yes.
we have the featherlight, but at the same time we have a box with a 5-star sticker on it. 5-star Credit Union is one of our biggest sponsors. They have sponsored us since we were Robotics, and they are still sponsoring us as we are now the Ridgecrest Robotics Space, or Ridgecrest Space Program. This right here behind me was made by a high school student last year. She's a senior. And she made it. It was just, she loved, robotics. She had done robotics, and she kept doing it even when we turned to the space program.
This just in. Heading is the direction it's going.
Yeah. So now we know what the heading is. So heading is the direction it's going in. So it was going.
It said 124 last time, so
Yeah.
that would be east.
Yeah. So as you can see right there, it is going in
That is the graphs of,
the altitude.
but it's time versus altitude. So it's like, how can I explain it? So you have the time and then the temperature. So you have how much time has elapsed and then how much temperature has.
Yeah.
And as you can see, the more time has passed, the higher it goes. So the lower the temperature drops every minute?
Yeah.
2 minutes. Minute. Yeah.
That's just so cool. It's there's our spot GPS. It is getting a ping.
That means it's also on, which is also good.
Yes, everything so far has been on, and that is just amazing. We've had some complications in the past with things not being turned on, and all that kind of stuff. Do we have any cool FPV photos to show? So that's a pretty good. That's so
ground.
cool. So that is it showing our planet or the ground of our, it's so high up you can see it now, and oh my goodness, it's so pretty. I know it doesn't look, it's kind of like a blurry photo, but it's so cool. Actually, so I got to talk with Mabry, our FPV manager, and I just remember it being so cool, watching him. He was excited for the also, Justin, we are at 17,000 feet, so we're
way up there.
We are really close. So that is Mabry. He is our FPV manager. I got to interview him a couple weeks ago, and it was just so cool to watch that. He's capturing, like a bird's eye view. He's seeing everything from the view of
a first person up there.
Yeah, so it's like a person is actually up there taking photos for us.
Hence the name,
and,
first person view.
So we're gonna watch this interview, and y'all get to hear a little bit of background on that.
I'm Annalise, and I'm here with Mabry, and we're just gonna talk a little bit about his job. So, what is your job?
I will be taking the role of FPV manager.
What does FPV stand for? FPV. I need to talk.
FPV stands for first person view. So I will be monitoring pictures coming in from the balloon.
So you'll get live pictures from the balloon,
Yep.
and well, that's kind of cool.
Yeah.
I couldn't do that. obviously. That's why I'm not doing it. Okay, what, I guess you kind of already answered this, but can you expound on it? What does your job entail?
A lot of computer stuff that I don't quite understand yet, but I hope we will get to that point. I mean, really, I'll also be telling the producer that we have a good picture coming in, so that the reporters could talk about that. Yes.
Oh, yay! I get to see the pictures. I'm so excited. You're probably way more tech savvy than I am. I can barely work this computer. I don't think I could work FPV stuff. I'm good. So what have you learned from doing this, and what do you think you will learn, like on launch day? I guess it's a two-part question. So my first part is, what have you learned from the job so far?
I've learned a fair amount about GPS and how we can get pings from like 10,000 feet in the air down to our school.
That's great.
So
okay,
cool.
And then what are you, I guess, excited to learn on launch day? I guess you really don't know what you're gonna actually learn, but like,
yeah.
I guess expecting of launch day.
Yeah, well, I'm expecting that it will go well, of course.
I think we all are, obviously.
Yeah. I'm expecting to learn a lot more about how computers work.
Yeah, I mean,
and things like that.
I would love to learn how computers work more. I don't know how to work this one.
I've seen it a couple minutes ago.
Okay. What has been your favorite part about doing this, and what are you most looking forward to?
Well, I have a lot of friends on the team, so it's been a lot of fun to do something with them.
Yeah.
That we're all working together to complete one
big project. Yeah.
Goal and project. Yeah.
Yeah. And then, what are you excited for? I think the most. I think launch. Yeah.
Day.
I think mine would be getting the pictures, like seeing them come up on my computer, just watching them come up. I would be like, oh, so cool! I'm getting actual live pictures from space. What is this? I can't do it, but so cool.
And the cool thing is that it'll be like just like in the movies, because instead of just boosh, we have a picture. It'll slowly
come in
line by line.
That's even cooler. So is this your first year on the team?
It is my first year on the team.
So it is my first year. So I'm learning along with you. Not probably as much as you are, because I have a little bit of an easier job, but still adds a lot. So I guess, what made you decide to join the team?
Well, I just thought, this sounds really cool. And,
I thought the same thing, honestly.
Like I mentioned earlier, I had a lot of friends doing it, so they said, you should come do this. So I was like, okay, do it.
Well, I'm glad you are doing it, because we have someone doing our FPV, which I can't do, so I'm glad someone else is doing it. Well, thank you for letting me ask you some questions and talk to you about this. Yeah, that's it. So, what you're seeing right now is the FPV box. So that, or
That's where our first-person view camera is. The big black stick to the left, to the left.
Yes.
On the picture on the left is the antenna that we're using our antenna to pick up the pictures from.
Mm-hmm. So
And
that is
our antenna.
That's the antenna on the top of the bus. So that we have to keep. They have to keep moving it so we can keep getting photos in. So we actually you interviewed.
I interviewed
Britton. He is the guy who wrote the code. He's the one who is on the bus helping them with the antenna.
Yeah, so the antenna, we have to kind of keep it pointed at the balloon.
Mm-hmm.
And the way they do that is it makes that beep sound. And it makes a louder beep until you aim it at the balloon.
Yeah.
So imagine being in that bus with the constant beeping.
Constant beeping, yeah. I couldn't do that, but I'm glad someone is, because we wouldn't be getting these cool photos from space.
That is true.
Because it's just so cool. I mean, the fact that this is, I think, one of the coolest things I remember from class is hearing about the antenna. So yeah.
First of all, I'd like to just personally thank Britton for
Yes.
taking the time to write down the code for our FPV camera. And also, we interviewed Britton
Yes, we
about the code.
did.
And
I mean, you did.
just going to be completely honest, I didn't really understand some things he said, but still.
Hey, it worked. And
It works.
He was ready to explain, and just seeing that, it's just so cool. So yeah, we will get that interview up. So
My name is Leland, and I'm here today with Britton. So, Britton, what is the coding that you put in? I mean, not like every line that you wrote down in the Raspberry Pi, but how does it work?
So the code is it's called a native program written in the C programming language. And the reason it's called native is because it actually runs through a compiler to get turned into machine code that runs on the actual CPU. Previous versions were more experimental and weren't able to do that. But the benefit of going to native code is that we're able to run some more high-powered libraries that handle not only the camera but also the image conversion and transmission and everything, and it doesn't have to go through any kind of loading process. So the whole program is able to run all at once without ever stopping.
So how are we going to get the pictures from the balloon?
So the pictures are ultimately transmitted over radio frequency using a modulation technique called LoRa, which has its own dedicated radio chip for the receiver and transmitter side. So a big part of the programming was actually writing the code that sends the data to the LoRa chip and then gets the data off the LoRa chip on the receiver side.
So can you give me like a step-by-step from balloon, like right when it takes a picture to when it comes down and we have it on one of our laptops in mission control?
So the procedure is basically an infinite loop. It takes a picture and it's a raw 4K image. And raw image means that each pixel of the entire image has the full depth of color and lighting information. So once it takes a raw image, the raw image has to be duplicated so that we can save the full raw image on the transmitter's SD card. And then one duplicate of the image has to be shrunk down to a really small size and then converted to a JPEG, and then has to be converted again into a packetized format so that it can be sent in chunks over LoRa. Then each chunk is sent one at a time over LoRa and received on the ground. Then the receiver side, for every chunk that it gets, it will construct a new JPEG image, and then it will send the new JPEG image into a video encoder, which will convert that into a live stream that we can view as they come in.
What is one big challenge that you might have faced during the coding?
There are a lot of big challenges. One that stood out to me was the video encoder. It ended up being a lot harder to interface with than I thought, and it just kind of took a while to get that going. The LoRa chip has a pretty good documentation sheet associated with it, so if you just have the patience to read through the documentation, it's not too difficult to get it to do what you want. But that was another challenge, was having to pay attention to every byte that you send across the wire to the LoRa chip.
So I'm just going to make this connection. When we get pictures from the Hubble telescope, where it's a pixel by pixel, just slowly going to the scientist computers somewhere around here, it's basically that's what's happening, but faster.
I would really call it slower. So the Hubble telescope would not use something like LoRa because they have really huge high-powered equipment. The point of the LoRa chip is that it can work in very low-power environments, and the sacrifice is basically bandwidth. So the LoRa chip is entirely powered by the actual power pins on the Raspberry Pi. So it's running just like 100-ish milliamps of current, which is very low, versus the Hubble telescope, which is going to be running many amps of power. So I guess it's similar in principle that you're sending image data over radio back to a ground station, but in practice, it's going to be a bit of a different beast.
All right. Well, that's what I was thinking, more of a pixel by pixel in the NASA scientist world. But well, thank you for your time, Britton.
Thank you.
So that was Britton. He was our, he's the one who wrote the code. So this is the FPV that we have up right now. As you can see the box of instruments, and so this is one of the better ones we have. So this is a screenshot of our FPV. So you can see the box of instruments, you can see the ground, you can see the sky,
the clouds,
the sun. You know, all
you can't
all
see
the
the sun.
Well, no, you can't see the sun. I think we'd be blind. So that's a really cool photo. I like seeing the FPV photos. It's coming. We're also gonna go next. We have the featherlight. So we are at.
What's our altitude right now?
Yeah, what's our altitude? If we can see that, it is. Oh my gosh. Okay. It is at 30,963 feet in altitude.
31,000 feet if you're one of those people that round up.
If you're one of those people who round up, it's 31,000.
That is
me. That's not me. I'd rather have the practical, or not practical, but like every single thing. So that's our time versus speed.
What it means by versus is just how much time elapsed over how much speed I spent.
Yes, exactly.
They're not pitted against each other.
Yeah, exactly.
That's
so
what I thought the first year.
We have all of that. Again, as you saw in the FPV photo, that was our box, and it has a 5-star sticker on it. And we want to thank 5-star. Like, it's such a big part of why we get to do this launch, and all that kind of stuff.
And how they help the robotics team for the past 10 years.
Yeah, they've helped the robotics team for
Happy
a
anniversary.
long while. So it's pretty nice.
Temperature steadily dropping.
Yes, as we go up, the temperature drops because we are getting,
48.
higher up. So it's 40. Wait, hang on.
48.2.
Yeah, 40, blah, blah, I can speak. 48.2 degrees.
It is
now 32.
It is at the point of freezing.
So it
after
is
31
freezing,
minutes.
almost, or it is freezing.
It is freezing.
I know what I'm talking about.
Are you sure?
Yeah, so that's our data logger. As you can see, it's showing us where we're going. We're at 36,697 feet. So.
Okay.
Did I say it wrong?
No, I was just reading all the numbers.
So yeah, as our launch is going, we have put a lot of preparation, and we have looked up some pretty cool things that have, people like eat in space. And so in front of us we have Tang. It is what astronauts drink.
Spacified orange
in
juice.
Space. So this is Tang. It looks like orange juice.
It smells like orange juice.
It smells like orange juice.
But it's not
Yeah,
orange
so it's not orange juice. It is powder that you put into water. So you gotta taste it at some point. It smells like orange juice. It kind of smells good. Actually, that's not that bad.
It's not that bad.
I was about to say, I was expecting something like way different.
Wait, what is it? It's the Sunny D's. The little orange juice barrels.
That's what it tastes like. Yeah.
But watered
that's
down.
not like, it's very watered down because we just added it to water again as powder. It tastes kind of good. Like, it's not as bad as I thought it was going to be. I thought it was going to be like kind of sour.
Honestly, I wouldn't have minded if it was a little sour.
Yeah, it's a little sweet. But, so fun facts about
Orange juice
space.
is good. Food.
Space food, sorry. So space food first started out in tubes. And so, like, toothpaste. So you would, like, put it in your mouth and, like, squeeze it into your mouth. And just the thought of that is just so gross.
Another thing that I've read, because, how old was I? It was my brother's book. And it was about, how do astronauts burp in space? Because it was about how, Coca-Cola they wanted to be the first soda in space. Mm-hmm. So they brought Coke into space. Mm-hmm. So here's the thing. You know how just gonna explain the science of it. When you burp, it's because you have bubbles in your stomach and they're rising up
Yeah.
because of they're lighter than air. However, if there's very little gravity, the bubbles are just there.
Yeah.
They're not. So
that is weird.
it, from what I've heard, it wasn't very pleasant. But it
Yeah,
was still the first soda in space.
I will say, I think space, I mean, okay, that is decent. Like, I was expecting not what I drank.
I'll say I'd be the person who has like the bubbles of liquid everywhere. Have my
God.
straw.
You know, drink it, bro. So in space, they have special straws and like lids so the water doesn't float. Because we have gravity here, but in space, obviously, they don't have gravity. So the drink will float up into the air. So they have, something like Tang.
Still thinking how cool that would be just to have bubbles of
liquid.
everywhere.
So actually, that's pretty bad for the spacecraft.
I know it's bad.
Because if it gets into there, it can ruin the spacecraft. It can even ruin your sinuses. Because in space, astronauts are in space, they lose their sense of taste because their body fluids are shifting and all that kind of stuff. And it's just, all ready for that. You want to check in with the, the Army Man that we launched at the beginning, out of the little box that we had with the servo motor. You interviewed Cooper.
Yes, I did.
Yes,
I did.
Who is our launch site coordinator, but also he's the one who built the box and designed it, 3D printed it. And so we had that interview. And so it was cool to talk to him. I mean, like, to hear the background of that.
Mm-hmm.
Like, not that we're sending a real Army man to space, like, not a real person, but we are sending...
We're not sending someone from the Army. We're sending them little plastic
we're
soldiers
sending
with a
little
parachute
plastic,
on their back.
So we have that...
we had to cut off his legs, so...
Yeah. So, it's just cool to watch the interview. So let's watch this interview.
I'm Annalise, obviously, you know who I am by now. This is Cooper. So what is your job, Cooper?
My job is the launch site director. So my job, I make sure everything at the launch site is going smoothly, and I also make the NOTAM.
Okay, what is the NOTAM?
The NOTAM is the Notice to Airmen.
Okay, and are you notifying, who are you notifying, I guess is my question.
So I am notifying the
air traffic control, is that?
Air traffic control about what we're launching a balloon up, and they tell me if I am able to launch there.
So you're gonna tell them that we're launching a balloon and basically to watch out for it, or they're gonna tell us, no, you can't do that. We have something going on, but you guys can't do it today. That's pretty cool. You're contacting some pretty, I guess, not important, but like higher up people, and so I bet that puts a lot of pressure on you to do it.
It definitely does.
I would hate doing that, but I'm glad someone's doing it, because I think I would lose my whole, I wouldn't even know what to do. I would go so scatterbrained. So is this your first year on the team?
No, this is my third year on my team.
So will be the third launch? Third or fourth?
Third launch.
Okay, third launch. I know what I'm doing. So have you done this job before, or?
I have done this job, but it was a different name. I forgot the name.
It was a different title to the name.
It was a different title.
Yeah. Well, and from what I know, this team is smaller from other years, so we had to combine jobs. So I'm guessing you probably have a lot more on your plate than you did the first year.
Yes, I definitely do.
So, what is? I guess. Hang on. How do I word this? What has been, or what have you learned from past years or this year, or both, from doing this job?
That's a good question.
I guess so. How did it go the first time you did it?
So the first time I thought it went pretty well. but something went wrong and it didn't go through.
Oh, that kind of sucks. So I guess you're probably putting a little bit more pressure on yourself to have it down so you can just do it.
Right, but now I know how the call goes.
Yeah, so now you know how to. You've done it before, so you have a little bit of experience to, you know, back you up, I guess, in this part of doing it. Okay, what has been your favorite part of doing this job?
I guess doing it with my friends.
Yeah, I mean, that's kind of why I joined. I knew a lot of people on the team, and I was like, you know, this sounds like so much fun to do it with friends, and, well, that's why I'm here. And I think doing it with people you know makes you a little bit more comfortable and a little bit more like, okay, I can do this because I have people that'll back me up. I have that with me. That makes sense?
Yes, it
Yeah.
does.
Is there anything else about the balloon that you are like super excited about? Like about launch day, or I don't know, like something that you're really excited about, like launching the balloon. That could even be it. I don't know.
I'm excited to see what works this time.
What works this time?
Like if we can have the army man shoot out of his
Little
box.
barricade thing, not barricade.
And also the first person camera. I'm hoping that will work this year.
Yeah, I'm really excited to see how that works. I'm excited to see the pictures coming in from space. Well, that's all the questions I have. Thank you for answering my questions. I know some of them were a little, I guess, put a little bit more brain power than you probably wanted. But thank you.
So I'm here with Alex. He was on the launch site. He is our mission control director, and we're just going to talk about the Army Man. So what about the Army Man is going on right now?
So once we launched it, it felt like we wanted it to. It deployed, and once it deployed, it started going, I believe it went north, and as it was going north and down, it experienced an updraft, and an updraft is whenever it's like wind that just pushes it up.
Yeah, pushes it up.
And it just pushed it up to where we couldn't really see it, and just kept going north.
So are y'all still trying? Are they start trying to find it?
They are still trying to find it.
Okay.
Yes.
So what is our goal in finding it? So like, why do we want to find it? I guess is my question.
I guess just see if we can really.
Yeah. Like follow it.
Yeah, so we can track it, I guess.
Yeah. So does it have anything on it so they can like contact us, or?
Actually, there is a phone number on it. If you find this Army Man, please call the number.
Yes. Call the number so we can come get it and see what that is. So did you watch, like you were at the launch site, so you watched it fall out?
Yes.
How, like, describe, I know it's like not like, oh, it fell out, but like describe, I guess, how it felt watching it fall out, like doing it on time.
It was pretty amazing. Just knowing that it worked successfully.
Yeah.
I guess
that's just so cool.
Yeah.
It was really cool watching the balloon go up, and so I could even imagine, like, kind of scary thought, but something falling from the balloon. You were like, I hope it's the right thing. I hope it's the right thing. I hope nothing fell off. It's not supposed to fall off. But I'm glad it like deployed like y'all wanted. So that is the motor that we're gonna end up using for our egg drop in the future, right?
Yes.
So are y'all just like testing it with the Army Man? What's going?
I think that is.
You're testing with the Army Man.
Yes.
That's pretty cool. So again, Alex is our mission control director. He had to go to the launch site today because one of our members is sick. But he went and acted as our helium manager, putting all the helium in there, ready to go. So we are going to switch to our data logger, so that, or pictures, whichever one we can get up. And I want to thank you, Alex, for coming. And it was just really cool to see how this was working. So that's our data logger, and yeah. So we are at 38,678 feet in altitude. That's like really high. Like, and then our direction traveled is 11 miles. So it has traveled a very far bit in the last couple minutes. We are going to contact our recovery team and check in on them. Do you have any jokes, Leland?
Cue maniacal laughter. Let's see. What's a light year?
What's a light year?
Mm-hmm.
I don't know.
Well, it's the same as a regular year, but with less calories.
Yeah. So I just contacted Ty to check and make sure. And I'm now going to call him, and we're going to check in with them. Hey, Ty.
Hey,
So how's recovery going?
it's going good. It's headed towards, it's about to cross the Chattahoochee River, and we're on Highway 52.
Okay. So y'all are in the recovery vehicle, obviously. You're getting that ready. How is the satellite working? Like, how's
It's
that?
going good. Once we got out of Dothan, we got a lot better signal.
Mm-hmm. So on the bus we have, it's you, Ty. Ty, he is our recovery director. We have Britton, who wrote the code, and so yeah, they are traveling
On the road again?
on the road again. So can we see everyone in the bus, on the bus? So let's see if we can see people on the bus. So that's Britton right there. He's working on our, I'm guessing he's working on the FPV stuff. We have, who else is on the bus? Ty?
It's me, Cooper, and Roman.
So there's Roman. There's Ty. Let's see who else. There's our bus driver. Oh, there's Jackson. He is our cameraman on the bus. So that was fun.
Who's aiming the antenna?
Yeah, who's aiming the antenna?
Or is it a computer?
Hey, who is aiming the antenna? Justin is aiming the antenna.
Okay. So yeah, that's just so cool. I bet it's a lot of work on there. Y'all have safe travels.
Don't get pulled over.
We will check back in with y'all later. Okay, bye.
Do not get pulled over.
So that was our recovery team. There's our spot GPS.
Right over the Chattahoochee?
Yep.
Right? Yes.
Yes, that's what he said, that it was right over the
Chattahoochee?
Yeah, Chattahoochee.
It's a fun thing to say.
They are ready. They're following it. They're on the highway, following it. As I heard Ty say, they had a lot more signal in Dothan. So getting out of Dothan, the signal for the what do you call it? The antenna. Yeah, that thing. They are, they're just ready for that.
And quick recognition for why they get more signal in Dothan is because they have more antennas that can pick up this signal.
Yes. So, as a fun little experiment that we have an MRE. An MRE is short for a ready-to-eat meal. So we have a, what is this? Yes, we have a meal ready to eat, Leland. This is the chicken burrito bowl. So we're gonna get this ready to this is the heating pad. So we're gonna put the heating pad around this. Have it set. Are you gonna open it?
I really want to do it, but I have to show the instructions too.
Yeah, you have to.
Don't eat that.
Don't. Yes, Leland, don't eat it.
It's telling me not to.
How do we do this?
While holding MRE pouch and heater above lines on bag. What? So.
No, okay, we have to fill.
sleep.
We need to. I think what is happening is we need to. So while we try to figure this out, we will show y'all some FPV photos, so we can, get this to work. Hopefully it ends up working. Let's see if we have any.
Oh my.
Photos. It is loading right now, so we are not getting any right now. So we're going to go
Struggle through the MRE.
struggle through the MRE. We can do this, guys. Okay, let me just make sure. Opening the bag. We did this wrong. You're supposed to open it up here, Leland.
No, it says tear here to open the bag.
Tear says where that? Oh, I'm so confused.
Tear here to remove MRE.
Yeah.
Tear
Okay.
here to use the bag.
Tear here. Yeah, that's what I needed. Leland.
It's
So-
so, get the MRE out.
While we try to figure this out, we are actually going to have an interview with Alex. We interviewed Alex just now, but I interviewed him a couple weeks ago because he is our mission control director. And so we're going to have that interview queued up. It was really cool just to talk to him about what his job is and how important mission control is to us, and how we need a director to keep us all in line. So
Hi, I'm Annalise, and I'm here with Alex, and we're gonna just interview Alex on what his job is and kind of how it works. So Alex, what is your job?
I am the mission control director.
Okay, and what does that entail?
Basically, I'm over everyone in the mission control, like the GPS coordinator, over the reporters, I'm over the camera operator, and that's all I can really list right now.
So you're basically over me. You're in charge of what that is. Okay, so what have you learned from being in your position? Like, what is something cool you've learned, or something you've experienced that you're like, oh, I can use this like for the rest of my life, and not just for what we're working on?
Basically, I have to be able to know what I'm doing, and I have to be able to apply that to my daily life so that I know what I'm supposed to be doing in the future.
Mm-hmm. So just a random question. Do you have to know what everyone else's job is, or do you just have to know your job? Like, do you have to know what everyone else is doing?
I have to be able to know my job plus everyone else's job.
So you have like a million jobs.
Yep.
Is what I'm hearing.
Yeah.
I couldn't do that. I think this is my cat. What is your favorite part about your job?
My favorite part is probably just being able to help make sure
everyone.
everything's
Keep everyone smooth sailing so the balloon goes up in the air. I guess you're not with the launch team.
Yeah.
So throughout the weeks leading up to the launch, what is something you have to do, like you don't have an option, that you have to like get down pat so you can be ready for launch day?
That's a hard question. I'm going to get back on you with that.
Yeah.
So
I will say, I guess you have to know everyone else's job. So you have to make sure everyone else is doing their job, along with you have to be doing your job, which is kind of everyone else's job. You're kind of making sure nothing just falls apart and we don't have what we need. What is something cool about your job that you would want us to know that I would not know about your job? I'm asking a lot of the hard questions here.
Yeah. I like the go and no-go sequence. Basically, I call up the launch director and the recovery director, make sure that they are ready to go. If they are not ready, then of course they'll tell me that they're not ready.
Yeah.
And I'll figure out what exactly is going on, how to fix it, and I'll make sure that it gets fixed in a timely manner. So
Yeah, so we can, you
Yeah.
know, keep on track with our launch. So so there's 3 different teams. There's mission control, launch, and recovery. Do you have to contact recovery and launch a lot during launch day?
normally just once or twice during the go no go sequence.
And if something goes wrong, you have to contact them? Okay, well, that's pretty cool. I mean, I like your job, but like, I could never do it. I don't have the patience for that. My patience is enough. Well, thank you for taking the time to answer my questions.
Yes.
I can't wait to see how the launch day goes.
All right.
Anyway, that's it. Bye.
So as you can see here, we have the FPV. As you can see, there's not as many. There's like half of the pixels are gone. So we are at a really high altitude right now. I don't know the specific right now, but we are at -4 degrees.
Oh, and don't we use like a, what is it? It's not, I think it's either a AA or a 9-volt battery for the
Yeah,
FPV. So the battery is running out.
the battery could be affected by the heat. We are still getting pictures. We are at 54,775 feet in altitude.
Oh wait, in the last picture, did you see that faint little speck of blue? And oh look.
Yeah, so as you can see, so we're getting up really high. This is why, so the cold is getting to the battery. We are still getting pictures, as you can see, but we are missing some pixels because of the temperature-wise.
The battery's probably going to start dying, because this battery isn't going to last.
I was about to say, the battery will start dying. It probably is starting to die already, obviously, because we've been using it.
That faint multicolored speck, that was our feather light, I'm pretty sure.
Yes, that is one of our...
oh, that's pretty.
So as you can see, we are really high up because it's getting to dark blue into black. So like it's fading from light blue to dark colors. And it's just really cool to see the... like we're super high up. It's getting to a really high...
curvature of the Earth.
Thing. So the balloon will burst sometime around noon is what we are predicting. So it is
12:10.
So it is 11:27 right now, and so the balloon is getting close. So this is our data logger. We are at a temperature of -4.
That's cold.
That is really cold.
In case you didn't know that.
Yeah, it's crazy. We are at 54,000 feet, 55 if you want to round up.
Yes.
We are traveling at a speed of 51 miles per hour. Our
and
heading...
it is facing, let's see, this was here, 90.
Doing some math
east.
over here.
No. Heading, I think it's east.
Mm-hmm.
Heading is the east.
East, so it's heading east.
If you can't tell by the very apparent line,
so
I'm pretty sure it's going east.
Yeah, we are already at 54,000 feet. 55 for those of you who round up.
Me.
We have traveled 12.6 miles. That is, I mean, in the time, it has been up in the air for about an hour now. And,
for an hour and a half.
Yeah. It has been full for 2 hours. So that's just, it's really cool to see how high it is. Can we see the spot GPS? So that is where, so this will get a ping, what is it, every 5 minutes?
Mm-hmm. Yep. And it's set onto a mode where it's live, so.
Yeah, so as you can see, there's a little bit of a curve into it, so that means the wind is directing it. And it's getting ready to go. So
It'd be so much easier if wind didn't exist.
If wind
then
didn't
it just goes
exist.
straight up and come back.
Because then it would just go straight up and down. But then that would have the fun adventure of the recovery team. So I had an interview with Ty. No, you had the interview with Ty. Someone interviewed Ty.
I interviewed Ty.
So one of us interviewed Ty, and he's the recovery director. And so we got a little bit of insight why he wanted the job and what all was into the preparation of that. So let's watch that video now.
Hello, my name is Leland, and this is Ty. So, Ty, what is your job?
My job is the recovery director. My job is to make sure that the satellite is still working on the vehicle so we can point it towards the balloon and get the data from it that we need to.
That's the FPV satellite, right?
Yes, it is.
Alright. What have you learned from doing this job, or what will you learn from doing this job?
I learned that communication is very important so that we know where the balloon is at and where it is headed.
Alright, what is going to be your favorite part of doing this job? Like, why did you sign up for this job?
I signed up because when I did it the first year, I really enjoyed the adventure and the unexpectedness of it.
How was your first year?
It was good.
Like,
Long
explain the story.
Rode kind of towards Georgia. Forgot exactly where we were at, and it landed in a peanut field. And so we had to walk across that peanut field to get it, walk back, and it was still in one piece.
Yeah, the second year wasn't as well.
No, I was not on that recovery, and they got stuck in a tree.
Every time I think of the recovery crew, I had to interview the recovery specialist about everything that he's going to have, and I just imagine, the meme with the T-Rex with the little plastic rabbit on it says, I can do anything.
Mm-hmm.
That's the one thing I'll bring when I go on recovery. Alright, what is a challenge in your job?
Challenge, probably having to change directions really quickly.
So, you said that you have a satellite on top of the vehicle?
Satellite. So this time, we're gonna try to get pictures from a satellite, and to do that, we have to point it towards the balloon to get a better picture.
So, how hard is it gonna be to follow the balloon if it's in the air?
We're expected to go at least about 2 hours south.
Oh, that sounds like so much fun. Road trip.
A lot of water.
Let's hope this time doesn't land into the Gulf of Mexico.
Hopefully not.
Just keep remembering that's what everybody says. It's probably gonna land in a swamp or the sea down south.
Most likely, actually.
We're gonna catch that jet stream that's coming this way.
Definitely.
The unexpected jet stream.
Mm-hmm.
So, you already explained to me what made you want this job, that you had it your first year. What did you like about it the first year?
I think I like the adventure and just a smaller group of people that I got to work with.
You like the car ride with the 2 other people?
Yes, it's very peaceful, but at the time that the balloon's not in the air.
I'm just gonna go on a limb. Guess it won't be that peaceful now that you have a satellite that someone has to keep pointing on the balloon.
Yeah, we know how close we're pointing the satellite to the balloon by the beeping noise.
Boy.
The stronger that it gets, so that's not going to be something that I'm looking forward to.
It's gonna be constant beeping the entire time. Yeah, I jumped out a window. Jump and roll.
I'd probably shut that thing off.
Well, thank you for your time, Ty.
Thank you.
So, as that video was going, we had our MRE ready, but as we have that, we have our data logger. We have a 58,000 feet. We're at 58,000 feet in altitude. So
That's halfway there.
It's halfway there. We're getting there.
Pretty much.
Well, we're halfway to 100,000. So we go a little bit more, and we'll be able to go. It is travel 27 miles. We're going at 34 miles per hour.
Supposed to hit a jet stream. It was only like 12 miles. Well,
yeah, it was 12 miles before the interview, so it went far. So as the interview was going, we got our MRE ready. So we're ready to try this, I think, MRE. We're not ready to try it.
I don't want it.
We have salt and pepper. Do we need to put it on there, or are you just
Nope.
going to eat it? Okay, you ready?
No.
I'm not ready for this. Are you?
No.
No. Okay, good. It smells good. It smells like a burrito. So this is a burrito bowl,
It doesn't
a chicken
look like a
burrito bowl.
burrito.
Okay, you ready?
No.
3, 2, 1.
No.
Okay, it wasn't that bad. my opinion, it wasn't that bad.
No.
And we also have pepperoni pizza crackers. Oh god. Definitely does not have any seasoning on it. I can tell you that.
Well, you
But-
just coughed all over them. I don't want one.
I did not cough into those. I coughed over here. You ready? Okay, that was actually worse.
Worse?
I liked the burrito bowl better.
Scratch that. Reverse it.
Whatever. Okay. So we're going to check in with everyone
Remind me
before
not to have dinner at your house.
Praise chameleon. We're going to check in with the FPV right now. To see how that's going. Oh, that's a pretty
that
picture.
looks a lot better than all the other ones.
Yeah, it's really pretty, and as you can see, it's kind of going slow, and the pixels are coming in slow, but it's because it is super cold. So we're getting that. But we're going to check in with everyone. Do a little recap on the burst that will happen. So we're about to take a break, but you are going to, talk, do your thing.
I am?
Yep.
Oh, okay. So, the balloon is, what is it? I wrote it down somewhere. Let's see. Here.
You have it somewhere.
So it was, uninflated, the balloon is around 72 inches, question mark? I think that's what the two apostrophes mean. The diameter is 72 inches. You inflate it, it goes up to 22 feet in diameter. And when it bursts, because the atmospheric pressure is getting less and less, so the helium's expanding, and the balloon's getting bigger, it's 27 feet, which is a pretty big balloon.
Yes.
You're welcome
Yeah.
for my start.
Yeah, you were good at that.
But the way it bursts is that the atmospheric pressure gets less and less, which means that, so if there's two opposing forces, and they oppose each other, but one gets less, the other gets more, it expands and it explodes.
Yeah.
Latex only does so much.
Yeah. Well, so it is predicted to burst while we are I need to talk, guys. So it's predicted to burst while we are taking our break.
We
It's a
must
lot of words.
articulate our words.
So,
to the people on the
I want to
camera.
thank our sponsors. So we have 5 Star, who has sponsored us for, multiple years. Even as a robotics team, they sponsored us. Now they're sponsoring us as a space program. Airgas,
who donated the helium.
Yep. We also have
Area? No, wait. Is it Tactical Area 51 or Area 51 Tactical?
yes.
Area
So
51
there's
Tactical.
Area 51 Tactical. They have.
Look up their website. They got stuff.
They have a website. There's the address on there.
I might go look it up. It looks kind of cool.
Yeah, it does look cool. We have Tom Sneed, who donated some for our launch. We want to thank him. He is a family member of one of our team members. So we want to thank him for the money to do our launch. What's our next one? I don't even remember. We have Fast Signs of Dothan. They will,
Their
not in
signs
the
will be
names.
fast.
Their signs will be fast. They make signs for people. We have, again, 5 Star Credit Union, who has sponsored us as a robotics team, and now it's a space program. And I think that's it. So we're going to take a break, but we will be back, and hopefully, fingers crossed, our balloon has burst so it can start sending, and so we can, get that ready. We will be back.
This is me signing off.
So we are back and ready to continue with our launch. We have the data logger. Let's check and see how high we are. We are at 76,893 feet. So we are almost to 100,000 feet.
It's going up a little slower.
It is going up a little slower, so that could mean that it's getting ready to, yeah, sure, burst. But I think we are getting close. But hopefully it stays up for another, 25,000 feet? Yeah, so something like that. So it needs to go up just a little bit further, and then we will have gotten to our goal. Hopefully we get to our goal and we can do this. So it is going at a speed of about 30 miles per hour right now. It has traveled 38 miles. So that's pretty far. So they are past.
Just basing off what I saw on the what's it called, flight predictor. Like we're almost over burst.
Yeah.
Where they predict the burst.
So we also have the FPV. We are still getting some fuzzy photos because it is so cold.
And it's also super high.
It's also super high and super cold, and the battery could be dying. There's a whole bunch of factors that could be going into that. So we're still getting photos, and it's just taking a little bit longer than it was at the beginning, where we would get one like that.
But on the FPV, I don't know who came up with the idea. I'm just gonna guess Britain. He came up with the idea of there's an SD card in there that has 4K, really
like
good
that.
photos on there.
Yeah.
So once the balloon comes back down, we'll have hopefully better pictures to post.
Yeah. So we also have our spot GPS. If we can get that up to see where everything is. So that is the coordinates right now.
As you can see, it is bouncing up and down. I'm kidding.
Okay. So that just means it's moving. It's continuing to go.
With spot GPS, what I've heard is, and what Mr. Bragg told us, is to not trust the altitude. Because it is not at 5,100 feet.
Exactly. So it is at almost 80,000. So we're pretty.
It's only off by 75,000 feet.
Yeah. Also, another thing about our team is we made a mission pin, and me and Leland are both wearing our mission pins. So we had Isaac. We had him draw the little army man on our, what do you call it? On our pin. He designed our pin. We also have our logo, which is behind us on this thing.
And behind us, literally, it's on the back of our shirts.
Yes, it's on the back of our shirts. We have team shirts. The logo for Ridgecrest Robotics and Space Program it represents our past and our future. We started as a robotics team in 2015 and completed in robotics until 2024. Oh, and there's our pin. Mabry is holding it up for us. As you can see, it's a little Army Man. This flight was called Flight FPV. Just a reminder, FPV stands for first person view. So that is our pin. That Army Man is hand drawn. One of our team members, Isaac, he drew it by hand and put it onto the computer for us to have it. So
Round of applause for Isaac.
Yeah, Isaac. So yeah.
I can't draw an Army Man.
I can't draw at all. I wish I could.
I can make a square.
So so there's our pin, a little bit closer up, and there's our logo. That is our, I guess, that's our theme verse. Because, I mean, space is pretty cool, and if it weren't for God, we wouldn't have space that we could, put a balloon up into space for. So we have a new ping on one of, I think it's the spot GPS. So if we can get to that. So there's our ping. It is
still not at 5,000 feet.
Yes, Leland. We all know that, I think, by now. So we are really far into our launch.
That's
We are
Georgia.
getting close to Newton. So we are getting close to our what is it called? Our projected flight. How far we're supposed to go, or we are predicted to go.
Yeah, there's the
So
yeah, there, where the little hand is moving.
we're getting there. How high an altitude are we? Let's see. We are 103,000
That kind of
feet
shot up
in
that
the
shot
air.
up a
That
bit.
shot up fast. We broke the record. Because it was 100,000 feet.
Huh.
We broke the record by 3,000 feet. So,
Everybody cheer.
yay! So we are almost to our goal. We did not break the record, guys.
Everybody
We're
do
wrong.
not applaud.
We are wrong. Our predictions were wrong. Whoops.
So, we made a mistake.
We did make a mistake. We are close though. So the record is actually 118. 118,000 feet. So we're getting there. So we gotta
Looks
get
like
to
we hit
120.
The bit of the atmosphere, I don't remember what it's called, but where temperatures go up a little.
Yeah, so
By a little, I mean by, let's see.
the temperature is 28 degrees. That's cold.
But
below
it's less
freezing.
cold than the -4.
So we
Maybe
did not break the
0.
record. Sorry, that was a miscommunication.
But we almost broke the record.
But we are getting close. We shot up fast. Our vertical rate is 1,057.
It accelerated.
It
It
did.
used to be 950.
It did.
It went up by 100.
Again, we are almost to our predicted flight path ending. So yeah, we have 15,000 feet to go before we
Break the record.
break the record, and we can do it.
We sound so excited.
I know, right? So we are going to check in with our what's it called? Recovery team.
Vehicle.
We're going to start to check in with them to get that ready. So.
But before that.
So.
But
Before we do that, do you have a joke?
Yep.
Oh, you have a joke. Let's get a joke out here.
Actually, let me find one.
Okay. Well, how about this? We have a whole bunch of jokes. There could be something.
Why didn't the sun go to college?
Why not?
Because it already had 1,000,000 degrees.
Okay.
Why couldn't the astronaut book a room on the moon?
Why?
Because it was full.
These are so. Oh my
Corny?
god.
You're welcome. Why did the Americans win the space race?
Why?
Because the Soviets were stalling. Stalin? What's his name?
I think it's the fact that you
What
don't
did
know
the
how
astronaut
to.
say when he crashed into the moon?
What?
I apologize. Love the dead silence of Mission Control, by the way.
There's absolutely no.
Sorry, I'm trying to get in touch with you.
Oh, okay.
I like Gideon's fake laughter better.
At least we're trying.
Knock knock.
Who's there?
Solar.
Solar who?
Solar, are you going to think of a better joke?
You better.
Okay. Why did the cow go in the spaceship?
Why?
Because it wanted to see the moon.
Why did you pick so much corny jokes? Okay, wait, hang on. It's my turn. Hang on, I gotta find one. What is an astronaut's favorite board game?
Favorite board game?
Monopoly.
Oh.
Yeah, you were really close. Okay. Well, I think I have some more space food. You want to try some more space food? No. Oh, hang on. It's good space food. Are you ready?
Do I have a choice?
Yeah. No.
Oh.
You
well
don't have
then, I guess I'm in.
Okay, you ready? We have frozen sweet tarts.
Okay, those are.
Freeze-dried sweet tarts.
I've had those before.
So, the reason people do freeze-dried food in space is because it's lightweight. There's no water, so it's super light, and it's very long-lasting. So you can have it in there for, a really long time, and they're long-lasting. So, okay, recovery team is ready for us. So, we're gonna call recovery and see how they are doing.
Hola.
One moment, please. Hey, Ty. How's it going?
It's going good. We are trying to get towards, what's that place called?
Camilla?
Kind of towards Colquitt, Georgia.
Yeah.
We're supposed to go a little bit past it.
Okay. So, how is the satellite working?
It's working good. We're getting a bunch of pictures. The altitude is about 103,000 feet is what we last got.
Yeah. That's what we had. So, how's just the ride? I mean, y'all are trucking along.
Very bumpy back roads.
Yeah.
Sounds like fun.
Yeah, sounds like so much fun.
Just got on 91.
Yeah. It looks bouncy from what I've seen. Y'all are going up and down on back roads.
I'm getting a little sick.
Leland's getting seasick, but not seasick because we're not in the sea. So space
sick?
car sick. Yeah, car sick. Yeah, you know what I meant.
Vertigo?
Well, y'all are trekking along. Y'all are getting there. So can we see the outside, like outside a window or something, to see the surrounding? Oh my, that's really pretty. It looks.
Country road, take me home.
So what? We see a lot of trees, and that could be a problem. So, what is y'all's plan for the retrieval of the balloon?
Our plan
Yes.
is that we can hope that it lands in a field, and if not, play it by ear.
Yeah. I know. Last year it landed in a tree, so they had to get the owner to shoot it down. But I bet there's some way y'all can figure it out. Hopefully it doesn't land in a tree and it opens in a open field. Do y'all have any equipment with y'all that would help y'all retrieve?
What is the equipment? No, I was talking to Ty, not to you. I know what the equipment is.
We have rings if we walk through the woods, just so we don't get shot. And okay, I think we found what we're gonna eat on the way back.
You got money to eat.
That's pretty much all the equipment. Just some rings since it's hunting season. Walking through the woods.
How about a ladder?
Probably not a ladder because with how uneven the ground is, if we get a ladder set up on a tree, that's gonna be dangerous.
Yeah.
How about a very long stick?
There's only so much we can do, and
They
hopefully
make extendable sticks.
we're just all really, really hoping and praying that it does not land in a tree and it lands in an open field.
Or a swamp.
No, it shouldn't land in the swamp. That would
never
ruin
know.
everything.
It's Georgia.
Yeah, we'll do what we can and hope it works out.
Yep, that is very true. Well,
Wait, Ty.
Yes.
Give me a second. What was it?
What are you doing?
It's up here. Oh yeah. What type of songs do the planets sing?
I got no clue.
Neptunes.
That's good.
Well,
a good one.
we wish y'all luck retrieving the balloon. We will check in with y'all later. Have fun.
Okay, thank you.
Bye.
Bye.
So So that was recovery. They are trucking along on our thing.
Technically, it's a
Oh,
bus,
no.
so would it be busing along?
Yes, busting along, sure. So, do we have any new pictures?
That we can see.
Very slowly coming in.
As you can see, this is a great blob of the Earth.
Well, okay, so if you think about it, one, it's really cold up there, and so it's adjusting to that, and getting all that, ready. We have had a burst. From what I was just told, it has burst.
Oh, the altitude is definitely lower than it was
Oh,
before.
definitely. So that means it has burst. We have had a burst, guys.
What did we
So
get
what did
what
we
we
get
wanted?
to our? So it looks
So
like
close.
we were so close. We got to 103,000 feet.
Nice.
We are so close. We were so close. But, okay, last time we could not track the data.
So we might have broken the record last
So we
time.
might have broken the record last year. We just don't know.
Maybe.
But that'll be our goal, is to keep working on that. But, hey, we've had a burst. That's pretty cool. So, it is falling at a very high speed. I mean, it was 100,000, and now it is at 46,000.
Okay, so let's look
We
back.
can always get to it. The vertical rate is negative 60,000. 6,277.
Every minute it's dropping that many feet.
Yes, that's crazy.
So it's gonna hit the ground in, I would say, about 5 minutes.
About 5 minutes. Yeah.
Alright, so back to the estimations of those 4 people. It was below 127,000 feet. It was above 67,000 feet.
Yep.
And it was below 121,000 feet.
So we got really close.
So we all lost.
There's some FB feed photos coming in. As you can see, you can see
It's still kicking.
It's still going, and it's about to fall. So, I mean,
It's not about to fall. It is falling.
As it is falling, it is going to fall to the ground quickly. So we are getting to that.
Oh, that looks good. Is that the ocean?
So hopefully it does not,
Not gonna go in that lake.
hopefully not.
Not in the lake.
It went really far. Definitely not as high as we were expecting, but
it went over.
It did come to a good thing.
I believe it went past where we saw. Oh, where it said it. Bird.
So, yeah. So we actually did not do this at the beginning, and I forgot to ask you. But why did you join the team in the beginning? What was your interest?
I wanted to do it last year when I believe I went to the orientation. He was talking about the medical robot that they had. Not last year, but
Year.
This is 2025. That would be 2024. Then the year before would be 2023.
Okay. So
I wanted to go then, but I couldn't because I had to get a credit for physical science.
Oh.
But then the next year, biology, which I also had to get a credit for, was moved to second hour, or the second hour of school, so I could join the robotics team.
Yeah, it's pretty cool.
And then Mr. Greg called me up one day. He's like, "Hey, you, how do you feel about being the reporter?"
Well, I mean, you're doing a great job.
I was the kid who sat in the back of the class doing that.
Doing
Anti-social.
Okay, sure. So.
How about you?
Oh, well, so last year my brother was on it, and I really enjoyed watching, the whole thing come together, and I wanted to do this. I'm glad I got to do it with you because I know you, so that helps.
It's much easier to report with somebody who you know.
And it is, especially when you've been known each other for longer than just
10 weeks.
10 weeks. But we have a GPS ping, so let's look at that and see how that's going. 46,000.
It's below that by now. We just haven't had a ping yet.
Yeah, we haven't had a ping yet, so on that, but it is really close to where we had our prediction. As we talked about in the beginning, one of our future plans is to, drop an egg from space. As we've seen, there's our ping. There's our ping. It's really close to where we predicted that it was, or where our flight predictor predicted it to fall.
The flight predictor predicted.
So, this one says it's at 27,000 feet.
Okay, so how to go up, but we had it. You know what? Never mind. Just don't trust the altitude.
Don't trust it.
But
I mean that's pretty close. What altitude are we at? If that has gotten a ping. I don't know
wait,
if it
I
has.
think I know what happened. It was the featherlight. It might be. So with the featherlight, it's like a big umbrella, but there has to be at least one antenna under the umbrella. And if it gets low enough, it can't reach the antennas. So if it was falling fast enough, then might not have the umbrella yet.
Yeah. So, as you can see, there's the FPV. They're coming in a little bit more clear now, and that is because we are dropping at a pretty fast. I mean, we're dropping at a fast speed, so it is getting warmer and it's getting further down. So it's a little bit. They're coming in a little bit more full than they were up really high because it's getting warmer as it's falling at the speed that it's falling at.
Hey, it's also upside down.
It is.
Now it's sideways.
So, but you can see, like, from what the FPV was, you can see how far we've already fallen from where we were.
Now it's not the atmosphere we see, but the clouds.
Yeah.
Yeah, so I'm pretty sure we're too low for the featherlight to give us any more data.
I think we are too.
Because what's 5 times 6?
The featherlight.
340,000.
Do the math.
I'm doing math in my head.
So yeah. You and I could try these now?
Yes.
Okay. Well, you can try
mine.
No, you took it like so, what do you call it? He's looking at me. That's good.
Well, that's hard.
Well, they're sweet tarts.
But it's so sweet.
So, as I was doing some research, just for some fun things to say, a random fact I found about space was that space is silent because there is no air, and the footprints on the moon will last for millions of years because there is no atmosphere or water to erase them. So,
if I went there with a feather duster, though.
Well,
I'm not going to, but I'm just mentioning if I did so.
Yeah. As you can see, there was a featherlight photo that was really cool a second ago.
Did you know that the sun is so big, it contains about, what's that number? 99.85% of all the mass in our solar system.
Wow.
Which only leaves 15% for every planet.
That's cool.
No, not even 15%. 0.15% for every planet.
That's cool.
Which is a little less than one.
Yeah. So, if you can see, there's an FPV photo that we have. It's only missing a couple stuff. So we have some photos from 100,000 feet up in the air. So that's, pretty cool. We
Just
can get those.
Another space fact. You know how days closer to the sun, they're shorter. You get farther away, the days get longer.
Yeah.
Like a day on Mars is 39 minutes longer than a day on Earth.
Yeah.
Well, in Uranus, the tilt on the axis that makes it like almost completely sideways makes a day 17 hours and 14 minutes.
Wow.
so it makes the day go
There
faster.
you go. So if you can see on our spot GPS, there is more pings that have been coming in, and it is past where we where it was predicted to go.
Wait, is it?
So that's, I mean, it's cool. It's gone further because it's supposed to land just past the river, and now it's even further past the river. So that's really cool. And then so it says it's at 18,000.
No comment
but it
on
went,
the altitude.
Yeah, it just yeah. So
The
there's
ground
another.
is getting closer.
Yeah, there's another FPV. The ground is getting closer.
And the picture is filling itself in
It
a
is.
whole lot faster.
It's filling itself in a whole lot faster. We're actually getting full pictures
We're actually
coming
getting
in.
good pictures.
There's a bunch of stuff with that. As you can see we're getting really, really close to the ground. Well, closer than we were, obviously. It's cool to see like how far we went up, and now to see the FPV photos.
Do you have any updates on the Featherlight?
That is
Or have we already?
question. I think
right.
we may.
That is a question.
I think we may have reached where we are no longer getting data from that.
Darn.
But that's okay. We still have our spot GPS that is still trucking along.
Still wanted to know how the altitude was doing still.
Yeah.
Now you can see it drops a whole lot faster than
Oh
it
my
goes
goodness,
up.
that light fell within a couple, not even 5 minutes. Within it being within it bursting, it already fell a lot. So, yeah.
Blue monkey bluey.
It's pretty cool. I actually
Vertical rate is how fast the balloon is going up, or if it's in the negatives, how fast it's going down.
Yeah,
and as
it's
you can
going
see,
down fast.
it's in the negative.
It's going down.
It's going down a lot faster than it's been going up.
It has. Hopefully it'll.
By about 7,000.
Yeah. If you can see the FPV photo that's coming in, it's very blue. We've gotten a sky view of this, not just a ground with a little bit of sky. So that's, I mean, pretty cool to watch it come down.
Take a minute to list all of our sponsors.
Yeah.
Alright.
All our sponsors.
Start with the companies, go to the people.
Yep.
So, a thank you for, Airgas. For Airgas, for 5-Star Credit Union, for Area 51 Tactical? Yeah, Tactical. I couldn't say the word. And for for Fast Signs of Dothan, for, what's his name?
Tom Sneak.
Mr. Tom Sneak. And for even more people.
We want to thank Steve Price, and we want to thank Ridgecrest for letting us video here, and doing our, letting us have our motion control thing here. We also want to thank Mount Gilead Baptist Church for letting us launch from there. And
thank you to, let's see, what are those names? I can read them out loud.
You can read them out loud, yeah.
David Brunson. Oh, I'm gonna mess one of these up. I'm sorry, y'all.
Yeah.
Broxton.
Broxton?
Gannon? Yeah, that.
Mr.
Rich Carlson.
You can pause for 1 sec. We got a new ping.
Oh.
So it actually is going kind of vertical now. It's moving, definitely.
Status is moving.
Our estimated, I wonder what the estimated altitude is, since we can't see it.
It said around 18,000 feet.
That was the last one. This one said 4,000. So it actually has gone down a lot. From what I see, 4,000. So
that's
we
what
went
it
from
says, though.
Yeah, but that's the only altitude we have right now, and so that's, I mean, it's falling pretty fast. Are we still getting FPV photos?
I believe it just takes those photos every time. Like it finishes a photo, it makes another one, finishes, makes another one.
Yeah,
no wonder the battery's struggling. It's been taking pictures for the past 3 hours. Wait, I think it fell.
Oh, maybe.
Come on.
Maybe.
Load. No, wait, that might be it. If it's not loading, then the antenna's not on it. And the reason it might not be on is because it hit the ground.
Maybe.
Maybe.
Maybe it fell.
Now we're just waiting for the next ping. So as I was saying before, she really interrupted me.
Oh, sorry. I'm so sorry.
And a final shout out, or not final, to the very last name on the list.
Yeah, you got 2 names. You got 2 names.
Oh, there's 2?
We have Rich Carlson, our recovery bus driver. He's driving our recovery team to
the balloon.
The balloon.
And for Miss Kim Thomas.
She has been here helping us with our cues and making sure we keep everything on track. We also want to thank the Summerlins, Greg Summerlin and Lori Summerlin. They put a lot of effort into being able to do what we do. And
the balloon is not inexpensive.
Yeah, it takes a lot of work.
And another shout out to GL Robotics for sponsoring us.
Yes. So we got one last ping, and that is, I think, all we're gonna do.
I know how much you'll miss us. Don't worry.
So it looks like it fell kind of in a field, maybe with some trees. So hopefully they're able to find it. I mean, they'll be able to find it. It'll take a little while. But, so we will have the space video out soon. But it fell. It fell. It fell. There's our mission control. They put a lot of effort. And so we'll have all of this edited and we'll have that out with the video from the balloon that we had. We'll have that out soon. Recovery video that we'll have. So yeah. And thank you for watching. We want to again thank all of our sponsors for sponsoring us. I want to thank everyone who watched the video. I know
thank y'all.
Yeah, what Leland said. But
Let me be simple guy. Thank y'all.
Thank y'all. So yeah, thanks for watching.